We are going to be learning about quadratic graphs. So here is a poster that kind of outlines all the parts of a quadratic graph when it relates to word problems. So we have the x-axis. All x values typically stand for time. And then we have the y-axis, and all y values normally stand for height. We have our vertex, our middle point, or our turning point. Once it reaches the highest point, and then it will turn and go the other direction. We have the axis of symmetry. We have our x-intercepts here. We have a negative and a positive one. The negative ones are typically not used in word problems because that would represent negative time, and there's no such thing as that. So we have our positive 0 is typically where we want to look at, and for certain situations, like we have this ball, a soccer ball here. The soccer ball will get kicked in the air. It will travel in a parabolic shape, so it kind of follows this. It will hit the vertex or its highest point, and then it will turn and then start to come down. And then here will represent where it hits the ground. So this first problem tells us to label the vertex, and what does it represent? So in this certain situation, our vertex would be here. And that would be the center of the parabola, right? And what it represents is the highest point of the water, right? It's the highest point that the water reaches. Next, we have a picture of a roller coaster, and it says label the x-intercepts. So the x-intercepts would be about here. And they would represent, at this moment, just looking at this first hill, this would be where you start to go up, right? And then here's your vertex, and then you would turn back around, and this is where you would return back at the bottom of that hill. Then we have what I think is a volleyball player. And you spike the ball, and the ball will travel in this parabolic shape. Here's the vertex. That's the highest point that the ball reaches before it starts to come back down. And your x-intercepts would be about here. And they would not represent going to the ground because it starts at a point. It depends on exactly what it says, but if someone is receiving this, so if it's like volleyball or if this is like football and this is coming from one person going to another person, that's where our x-intercepts would be, where it's caught. Or the x-intercepts could be represented down here at 0. So next we have a picture of a dolphin's jump. So they tell us to draw the x-axis at the waterline. So the x-axis would be here, and draw the y where the dolphin begins. That's a lot of crooked, but here, let's fix that a little bit. Our y-axis didn't fix it at all. It would be here. It would be more straight. Now, for word problems, what normally happens is we don't see the picture. We have to visualize the picture, but we get the equation. So what you're going to do with that equation is you're going to go over to Desmos. And you want to open up the graphing calculator, and you want to put that graph in. So negative 0.2x squared plus 2x. So here is the dolphin's jump graph, and this helps us assign some numerical value to all the parts of the dolphin's graph. So keep in mind the X values represent time, the Y values represent height. So once we have that graph, we're going to go and label the vertex. So the vertex would be here. And if I go over to my calculator and look at the vertex, I have a numeric value of 5, 5. So remember, this is an ordered pair. So the X value is 5 and the Y value is 5. So what that means is the X value being time would be 5 seconds, and the Y value being 5 would be the height. So 5 would be here at the height. So 5 seconds, in 5 seconds he jumps up 5 feet. How long does it take the dolphin to jump out of the water and back in? So you follow his path of him going out of the water. He starts here, and then he begins to go back in. So we're talking about an x-intercept, which would be here once he returns into the water. So to find that actual value, we need to know what is that point on the graph. So we go back into decimals, our graphing calculator, and that point is 10, 0. So remember that the X value comes first. The X is 10, the Y is 0. So the Y is height. So he is now 0 feet high because he's back entering the water. And the X is time. So it tells us 10. So how long does it take him to jump out of the water and get back in? About 10 seconds. If that unit is seconds. We don't really know what this unit is, but the number is 10. Next, it says, how high can the dolphin jump? Well, we can see, we already labeled that with this vertex. That's the highest point, as long as the parabola is shaped like this. So here's the highest point, and the Y value of that is 5. So he can jump 5 feet, or maybe that's meters. Maybe that's any unit. We don't really know the unit right now. They didn't assign that, but we know it's 5. And I'm using this 5 only for that, not this 5. This 5 represents how long it takes. Because height is the Y value. And then the last thing says label the x-intercepts, and what do they mean? Well, one of them we talked about. The 10 represents 10 seconds have went by, that's time, and he is at 0 height. And then the other 0 would be here. And if I go over to my graphing calculator, that point is 0, 0. And at 0, 0, that means the first 0 is for X, which is time, right? So no time has went by, and then Y is the height, and he is not any feet above the water. Or this is where he starts, and this is where he ends. That is also what that means. So this is more similar to what you will see. You normally don't get a graph or a picture. This one says a soccer ball is kicked from the ground and travels a parabolic path. The path can be modeled by the function h of x equals negative 5x squared plus 19.5x. So here's our quadratic, right? And I'm going to take this. I'm going to pause at this comma. I'm going to take this and I'm going to put this into decimals. And the output would be this graph. So I've already done that work for you. But I assure you, if you go over into decimals and type that in, you will get this. Now, keep in mind, we do not put in the h of x. We just need to put in the side of the equal sign where where we see the square and the remainder of the expression, not this part. This h of x, they say where h of x is the height of the soccer ball in meters above the ground, x seconds after being kicked. So h of x is the height. Height is normally y. So I can just replace this h of x and put a y. And that represents my y-axis. And then it tells me x seconds after being kicked. So I know that x represents my time in seconds. The question is, assuming the ball lands on level ground, how long is the ball in the air? So I'm trying to figure out how long the ball is up in the air. Well, that means I need to consider how much time it takes for it to go up and then return. Well, if I click here and I see that once it goes back to the ground, 1.949 seconds has went by, right? Because the x value is time. The y value of 0 is the height. So that is when it is back to the ground at 0. And this is how much time has went by. So when I go to pick this, remember we never use negative time. 0 time has not went by because some amount of time went by. 19.5 seconds did not go by. It's more close to 1.975. So that is our answer for that. All right, that is all.